Welcome to the Good Chemistry Podcast. I'm your host, Nick Jikomis, and today's guest is Dr. Michael Eisen. Michael is a professor in the Department of Molecular and Cell Biology at the University of California, Berkeley, and he's editor-in-chief at eLife, a nonprofit, peer-reviewed, open-access scientific journal. Throughout his career, he has been an advocate for open science, which is the free release of the results of scientific research. And he's also been critical of traditional forms of scientific publishing, which often place scientific results behind a paywall. Professor Eisen and I discussed a variety of topics related to how academic science is actually conducted, including how it gets funded and what's involved in running a research lab. We focused much of our time on talking about the business of scientific publishing. We discussed what scientific journals are and their history, as well as the business models of for-profit journals and how they work the way that they actually do. We also talked about open access journals and new ways that people are using technology to get around paywalls and access scientific work directly. Scientific publishing is an industry that most people have little awareness of, including many scientists, and the size and profitability of the large scientific publishing groups will be surprising to most people. So if you're interested in science, or even if you're just interested in learning about how a business like this actually works and how it interacts with the funding and the work that goes into scientific knowledge, you'll find this discussion very interesting, I think. As always, if you enjoy this content, please like, share, or subscribe to the podcast, either on YouTube or by becoming a monthly patron on Patreon. And with that, here's my discussion with Dr. Michael Eisen. Professor Michael Eisen, how are you?
Good. How are you?
Good. Where are you calling in from, and can you tell people who you are and what you do?
I am calling from Berkeley, California. I am a professor at the University of California here in the Department of Molecular Cell Biology and the Department of Integrated Biology. I run a research lab there. I study, mostly study fly development and fly genetics and genomics. We do a little bit of work on mind controlling parasites. I also spend a lot of my time working on trying to fix the dysfunctional system of science publishing. I, have been doing this for about 25 years. I've been heavily involved in the open access publishing movement, and more recently in efforts to kind of change the way that peer review is organized and carried out by scientists.
So in academic science, the currency is really publications. You're trying to produce research so that you can produce publications, so that you can get more funding to keep doing your research. And obviously that involves sending in papers to journals, and the journals publish the work. So even if you're a non-scientist, you may have heard of the big journals, Nature, Science, Cell, things like this. These are the structures that contain all of the scientific work that's out there. Can you just explain at a very high level, in very broad terms, what is a scientific journal and what role are they meant to play in an idealized scientific process?
Right. So first of all, just to give people a sense of the world that we're operating in, there are something like 50,000 different scientific journals. The scientific journal in its purest form is an organization of scientists, really, who come together to collectively assess the work submitted by their colleagues for their assessment, and to decide, both whether they are, scientifically valid, to do the sort of classic version of peer review where you comment on the actual science in your colleagues' work, but also to decide whether or not they're interesting and important enough to warrant the time of their, the people in their community to read. So scientific journals are, they're the mechanism by which scientists communicate with each other, and they're the place where the kind of two parts of peer review take place. The part where we decide whether science has done right, and the part where we decide, who's going to be interested in the work and how important we think it is to them.
50,000 scientific journals. Eventually, I will come to how that whole sector works and how it is that journals start and what goes on there. But first, I think it'll be useful for people that haven't been a part of academic science to understand exactly how it works. And I want to start with scientific funding. So how does a typical academic research scientist at a major university get funding? Where does that money come from? And what is it generally used for in the lab?
Okay. So and obviously there's no single answer to that question. So, but in the US, the vast majority of scientists who work in academic, research environments, their salary is paid for by the university, at least in part. So I'm paid in part to teach and I'm paid in part to run a research lab. But then the labs are almost always run by external grants that you have to apply for. So, in my departments, the typical grants would come either from the National Institutes of Health or the National Science Foundation, who are the major public funders of research in the US. And those, they have too many programs to keep track of, but the basic idea of them is you submit a proposal to the organization, it's reviewed by your colleagues and by people at the funding agency, and they make some set of decisions about what of the many different proposals that are sent to them, which ones are going to get funded and to what level of money and for how long. And those can vary from small grants that are in the tens of thousands of dollars that are meant for small research projects to, the biggest federal grants are millions of dollars and involve lots and lots of people. So it's a little hard to describe that world in any consistent way. Mm-hmm. There's also a fairly decent number of private funders, private nonprofit funders. So my lab, for example, is funded almost entirely by the Howard Hughes Medical Institute, which is very big private foundation that was set up by Howard Hughes with the large fraction of his wealth. And they fund 300 or so scientists across the country, kind of paying our salaries and funding our labs in a fairly generous way to do work that is kind of broadly related to medical research. And then there's dozens of other private funders that have varying amounts of money to support research like that. And there's a smattering of private funding in company funding in academic research labs, but that's a small minority of what goes on.
Mm-hmm. So a professor at a major university is running a lab. They also likely have some teaching responsibility. The university is paying you in part for teaching and in part for creating new knowledge through your research efforts. And so let's say you're a PI running a lab and you get a big NIH grant. That money then comes in, and what happens to it? What's the first thing that happens to it? Is it all going right into the lab to do the research?
No. It's a very elaborate system that I think very few people fully understand. So if I get a grant for $1 million from the NIH actually cuts a check to the university for something like $1.6 million. Obviously spread out over time. They don't give it all to them immediately. But say the $1 million goes to my lab and for paying salaries of people in my lab, and most of my expenses in the lab are salaries and reagents, things we need to do experiments. So, with the majority of that being salaries, and then the university takes some money on top of that. I think at my institution, it's something like 56% or something like that, on top of the money that I get in my lab as what they call overhead. And the overhead goes to support all the things the universities do that they don't directly bill me for. So I don't get a bill for, the people who maintain my building. I don't get a bill for the library. I don't get a bill for, I get bills for all sorts of little things, but the major infrastructure things at the university, just keeping the buildings up to shape and building new buildings and just running the place, mm-hmm. that is covered by the overhead. And it's a huge amount of money for the universities. A large fraction of the operating budget of universities comes from these kind of overhead on federal grants, to the point where even a place like the University of California I think I saw a stat recently where they get now more money from the federal government than they do from the state of California. So it's it's a kind of a major part of the operation of the university, especially a big research university like the University of California, that the faculty bring in research grants, and via those research grants we kind of fund the operations of the university.
And so I used to be in academia, and now I'm in the private sector. I'm wondering if there's any analogies we can draw between compensation in your world versus the private sector. So let's say you've got 2 or 3 professors at a university. One of them brings in a $500,000 grant. One of them brings in $1 million grant. One of them brings in a $10 million grant. If you were in the private sector and you were doing sales, say, your compensation would be proportional to the money that you bring in. Is there anything like that in your world?
There's not supposed to be. So our and again, like a lot of things, it's complicated, but our salaries at a public institution like the University of California are not supposed to be tethered to the income we bring in for the university. It's not considered conducive to our educational mission. And so faculty salaries at UC are set on kind of a scale, but there's a little bit of fudge factor. And the reality is our salaries are not explicitly tied to the grants we bring in. However, people get offers from other universities, especially private universities that have fewer constraints on what they can pay people, and they can, if you bring in a lot of grants, a university has an incentive to offer you various and sundry perks, both financial and non-financial, to try to lure you to that university. So I think it is definitely the case that on average, if not directly and explicitly, faculty salaries are a function of how much money they bring in for the university. And that's why, for example, I think in well-funded departments where the grants are big, the faculty salaries are generally higher than in like our history department, where they don't have that kind of lure for faculty to get offered tons of money. There are some circumstances where the feedback is more direct. I think some places like medical schools often don't pay their faculty salaries at all out of the university's budget. They're entirely raised by grants, and they're, depending on where the funding comes from, there's different constraints on what kind of you're allowed to effectively pay yourself out of your own grants. So I think it is definitely overall the case at universities that the more grant money you bring in, the more your salary will go up in accord. Although I think by and large, universities try to not make that calculation quite that explicit.
I see. So there's a bunch of scientists with a bunch of labs across the country at major universities. They're bringing in money for research purposes. A large chunk of that goes to the university just to fund university stuff, building buildings and so forth. A chunk of that then goes to your lab, which is primarily going to pay your graduate students and your postdocs, the scientists actually in the lab doing the work. And a good chunk of that is going to buying all of the stuff, the reagents and the equipment you need to actually do the experiments.
Yep.
So you do the experiments and you create a story. So you have to write a paper. Can you talk to people a little bit about what goes into actually writing a paper? Let's say it's a pretty good body of work that you're going to send to a high impact journal, or that one might send to a high impact journal. How long, and I know a lot of my questions aren't going to have one answer, but let's just kind of sketch the contours for people. How long is a normal research process? Are we thinking in months, years, many years?
I mean, I would say the typical, I can speak for myself, and probably fairly representative, at least of a certain, portion of the scientific world. Mm-hmm. A prototypical paper that comes out of a prototypical research lab is probably, several years of time, 2 to 3 years of time of the primary scientists who carried out the work. Mm-hmm. And usually there's a single point person who has worked with others in varying degrees on a project like that. So I've never done a full accounting of this, but I would suspect that the typical paper from my lab is probably, 4-ish years of time from the people who were carrying that work out. And, it varies. We've had some that came, where from idea to paper was extremely quick and didn't have that duration. And I have others that, where the fuse is even slower burning than that take years, they take decades to kind of fully mature. But in terms of the total amount of labor and effort and time that was spent on a paper, it's probably, on that order, 4 or 5 person years worth of time. And, some of that time is not directly reflected in the data that's in the paper, since every project has a long period where you're kind of figuring out what works, what doesn't work, what's interesting, what's not interesting. And then, once your thinking has crystallized around what the right experiments to do are and how to carry them out and analyze them, then there's a much more intense period during which you're collecting data that you are actually now thinking about publishing. Mm-hmm. I think oftentimes at the beginning, you're doing experiments that are really for yourself and for learning your way around the subject, at least for us. And then once you've done that, you kind of put 2 and 2 together, and you're like, okay, this is the topic, this is what's interesting, and now I know what to do, I know how to do the experiments right, and you do them. And probably the period of time between, when that happens is like, that can happen quickly once you've got everything in place. And then, you collect the data over the course of several months, and then several months of analyzing it and putting it together. And then the process of writing a paper, this is, I would say, I don't know what your experience was, but that is probably the most difficult thing for everybody in science, in the sense that, you are trained directly and indirectly in doing research. Like, you learn how to carry out experiments in the lab because someone shows you how to do it, and you learn how to analyze data and think about science by reading papers and talking to them. But we actually have very little. It's a very hard thing to teach, in the sense, because it's just one of those, you kind of have to do it.
Learn by doing, yeah.
Right. And so, everybody has a different style. I mean, I try to encourage, like, all right, figure out what your story is in your head, write it down, but this isn't going to be in the paper. This is for your own metrics, and then make figures. Mm-hmm. the unit of currency in a paper, if the paper is the unit of currency in science, by and large, the unit of currency in a paper is the figures. They capture your story, they tell the story, they display the results in the way you want them to be absorbed by the readers. They're kind of instrumental in setting out what you're up to. And I think the two things that are, they're also kind of the easiest things to make materially, because, people have writer's block, but they don't really have figure block, right? Like, because you can play around with it. It's a good thing that people don't seem to have you make graphs and whatever, we don't do it in Excel anymore, but we write code to make pictures, and you can play around with those quite easily until you come up with something that makes some sense. And you make, I mean, I literally been doing this the last week. I make the first figure, and then I go and make the second one, and the second one makes me realize that the first one needs some tweaking, and then I make the second one in concert with the first one. Then I'll make the third one, and I do the same thing over again. And so it's then once you've got kind of the figures laid out, you've got a story, and then you start to wrap text around it to explain what the figure's telling you, why you did it this way. And not everybody works that way. There's as many ways of constructing a paper as there are, mm-hmm. Different, ways of thinking about them. But it can be a very long, drawn out process to do that well, because, this is, just forget about all the infrastructure of publishing and the way it actually happens. I mean, this is what you're in science for. It's to to me, like, the distinction between science as a way of asking questions and science as an endeavor is sharing your information, right? Like I can be a scientist if I'm locked in a cave and no one ever knows what I'm doing and I'm applying the scientific method. I have a hypothesis, I test my hypothesis, I learn something and I do it again and again and again. That's science, but it's not science unless I, describe it in a way that other people can learn from it, they can build on it, they can benefit from what I've done. They can tell me where they think I've made mistakes, that we can learn together how to do science better. And so, you can conceive, we could make YouTube videos about our experiments or something. So it's not like science has to have papers. It's just that is the by and large still the way that we record the things that we think matter about what we've done, what our ideas were, how we did our experiments, what we found, and what we think it means. And so those are the elements of science, right? Methods, data, ideas, results, conclusions. Those are the basic elements of science. And, we share them in papers. And so they are, forgetting us for a second, the whole career infrastructure that's attached to them. And that, it really is true that like the scientific literature, which is the collective body of papers that have been published by scientists since they started writing papers. The scientific journal was born in the 17th century. It's been around for a long time. And, collectively, there's probably been, on the order of 100 million papers written, maybe slightly less than that, but something like that, that many science papers have been produced. And that collective body of information is it's like one of humanity's greatest creations. And so it's an amazing thing. It's so many problems in how we do it that you can sometimes get lost in the details, but in its collective value, it's, so much of our lives are improved and our intellectual life as well as our material life by things that are in the scientific literature. That, all these COVID vaccines, for example, right? They're born from the scientific literature in many, many, direct ways. And so I think it is useful to sort of step back and appreciate that, that thing that scientists have created over time is a pretty, it's pretty cool and amazing.
Yeah, it is really amazing. You've got this just giant corpus of information. Each one of these things is taking, on average, some number of years to do. And for those that have never done this, it's not a casual few years. It's a very involved and dedicated few years for each one of these things.
Yeah, again, I can't speak for everybody, and I'm not even sure this is the best way to function as a human. But like, the papers that I have done the work on, like, obviously as a faculty member now, I do less and less work on individual papers compared to the students and postdocs who carried them out. But back when I was in grad school and a postdoc, the years that went into making those papers that I published were those were years of a lot of work and effort and toil. So this is it's an immense amount of human physical time, labor, time, and mental energy that goes into each of those works.
So you've got some number of people that have put in that time and that effort. They've got a story that they think is really good. They've got results that they think are really exciting. So exciting that they want to send it to a top tier journal. What is that process like when you're submitting a paper? Let's caricature that for people.
So I think it's probably worth, before doing that, just describe when you say top tier journal. I think it's worth understanding the structure and a little bit of the history of this. Back at the beginning of when there were science journals, there was just science. They weren't differentiated, right? There was the Royal Society in the UK. That was scientists. Every scientist, whether you were a botanist or a microscopist or, I don't know what other scientists you want to think about back then, but like you were a scientist and you went to the Royal Society and you shared your results. And so, you might hear a talk by somebody, attaching electrodes to a frog's leg. And then the next day you'd hear someone, looking at the layers of rock in a mountain they were exploring, right? Like science was a single thing. Over time, as it became a profession where people, specialized, as more and more scientists got involved, there started to be more and more specialized venues for sharing your work. It started to be true that, like, if you were describing a new species of plant in your travels to South America, your audience, like the people who were, looking at the layers of dirt in coal mines in Finland, weren't going to be interested in the plant you were describing from Brazil. And so there started to be a differentiation of science into little pods of people who had like interests. And, back in the day when the means of conveying your ideas, so again, the Royal Society used to just have meetings. You just show up on Thursday night or whenever it was, and like someone would read their results, and there wasn't a journal because you were all there and you came and heard talks, right? It's like Zoom. And but of course, people couldn't come some week, or they lived in far north of Scotland or whatever. And so they started, as printing became cheap enough to do, they started to print, reports and send them around. And so that was, for much of the history of science, that was an expensive thing to do, right? It costs money to typeset, print, mail issue. And so journals, really in their current form, were born in the 19th century as to try to define audiences of scientists, and in some cases non-scientists, who were interested in the same type of stuff. So you would have there were some general science journals, the same ones that exist today came into existence in the 19th century, Science and Nature. They were meant to be, for the most interesting stuff, that like the kind of geology that you should care about if you're a botanist, or like a species that's discovered that's so interesting that even somebody who's, just, inventing, new ways of manufacturing metals into the lab, right? There were these general science journals that were meant to capture the most exciting stuff. And then there were a growing number of specialty journals that were the Journal of Botany, the Journal of Malacology, all these things, right? And they were partly a response to just the growing scale of science, and partly to the fact that the economics only makes sense if you print and mail things to people who are willing to pay for that piece of information. And a botanist isn't going to subscribe to a malacology journal. And so there is, what was born out of a kind of natural, it was born out of a natural kind of segmentation of the industry. It became, over the course of the 20th century, especially in the latter half of the 20th century, a way of measuring your success as a scientist. It became a particular feather in your cap if the botany work you were doing didn't just get into the botany journals, it got into the general science journals, because that meant that what you did was of sufficient import that everybody was interested in it. And so that system became hardened over time. And it particularly from the 1960s onwards, when science funding exploded, science grew as an endeavor, and it stopped being true that the people who were kind of deciding who should get funded or hired in departments were experts in every area of science they were covering. And so there was a little bit of if Nature says this work is interesting, we're going to believe it's interesting because the people at Nature know what they're doing. That was the assumption, at least. And then that notion that there is a kind of relationship between the size of the audience of a journal and how important the work it publishes has become kind of systematized in science. So it's not an accident that the top tier journals, the ones that people aspire the most to get into, or most people aspire to get into, are the ones that have the least specific names.
Mhm.
Science, Nature, Cell. Those are about as generic statements about things that they contain as you might imagine, right? Science is probably the most generic, right? Nature, maybe it's a subset of science, but it's still like very big. And cell, everything has cells. All of life has cells. So it's all right. I'm gonna piss off the people who think viruses are alive, but right. So there is this hierarchy that exists in people's minds where the more generic the journal, the more difficult it is to get into. And therefore, the journal started to behave that way. So Science, Nature, Cell made themselves, because they were attractive, they became very difficult to get into, right? They're like, the Harvard of publishing, right? They become appealing because of their name. So everybody wants to get into them. And now they can become really exclusive. And so, and I want to be clear, I think this system is terrible. I think it's a broken system. It's bad for science, but it is the way that people operate. So it is useful to understand it, that the ability to get your work into those journals is taken, figuratively, and in some parts of the world, literally, as a measure of your worth as a scientist, because if it is sort of equating the assessment that the journals do of what is going to be of interest to a very wide audience with science that is important. And you can pick apart that notion quite effectively, I think, but that is the pervasive idea in science. So what you asked the question, what happens? What happens is, if I have a paper that I think, even potentially belongs, I will say, I don't do this. So like this, I'm not describing this from my lab. We shun the system in many ways. So I did describe this generically. But the way it works is you pick a journal that, you think your paper belongs in. And usually there's a little bit of aspiration involved, right? Because you're rewarded, like, just like with college admissions, there's like people have safe schools. You don't submit your paper to the safe journal. Most people try to, go higher than they think the paper might, if they were betting where it would end up. And so, a lot of people send papers to Nature or Science, Cell. They reject, I don't know what the exact numbers is, but they reject probably 98% and something like of the papers that get submitted to them. Most of them they reject just at first blush. Some editor there reads them and says, I just don't think this is gonna make it, and they just say thank you, politely decline to publish. The ones that they think have potential, they then send out to peer review, and different journals operate differently. They all have editors who do that first level of screening. Some of those editors are professionals, usually PhDs, who decided that they were more interested in science communication than in doing bench science. And, usually these are very broad-minded people who can cover large areas of science and sort of just enjoy the process of reading about the latest discoveries more than they did making them themselves. And so there's either professionals who do that or active scientists who do that. There's a lot of debate in the world of which of these is better. I think they both have their pluses and minuses. So, but in either case, an editor looks at the paper and just makes some initial decision about whether it potentially could fly at the journal. And then if they think it can, they send it out to people who they consider to be experts in the field to assess the actual science in the paper. So
gotcha. So the editor is always a scientifically trained person and may or may not be a practicing scientist today.
That's right. So it depends on the journal, and some journals there's a mixture and whatever. But these are people who have been active scientists in their lives, and I'd say the vast majority of them have written papers, often many papers. So they have some experience on the author side as well as on the consumer side of science. And they're not, depending on the journal, they usually don't act directly as a peer reviewer. They're kind of overseeing the process, but they then, they use either their own knowledge of the field or database of reviewers to pick reviewers who they think are appropriate for the, to assess the science. And that usually means somebody who is in the field, does research like the research that's described in the paper, so that they can assess the methods and the details in a way that usually requires having some specialized knowledge of the field and the context of the work. And then, they're asked to do that in a couple of weeks. It usually takes them longer. And then they write a report that is partly a communication to the authors describing what they think about their work, and partly a communication to the journal describing whether or not they think it belongs in the journal, using their knowledge of other papers that have typically been published in the journal, and then and often some description of what, if it doesn't already belong in that journal, what it would need in order to get there. Mm-hmm. And so that's the typical components of a peer review: are direct comments on the science for the authors, editorial comments on the work for the journal, and kind of a roadmap in their own minds for how to bridge the gap, if there is.
And what's a typical number of peer reviewers that would look at one paper?
The typical number is 3, for no reason other than you need someone to break a tie, I think is the why 3. I mean, I think generally we feel like 1 isn't enough because, mm-hmm. There's often differing views. And 2 or 3 are probably equally useful in some sense, but, it's good to have a third person in the room to break ties. Anyway, it doesn't always happen. I mean, the journal I run, sometimes it's 2, sometimes it's 4. We often ask more people than we need, just because the median answer is no. And so because people are busy, and there's 2 million papers published every year, which means 6 million reviews have to be written. And it's actually more than that, since papers get rejected from one journal and then go to another one. And so it's probably 10 million, I tried to estimate it, somewhere between 5 and 10 million reviews are really written every year of papers. So if you're in a field that publishes a lot of papers, and you're generally regarded as a good person in the field whose judgment is valued by the journals, I get many review requests every day, just to mm-hmm. give some perspective on this problem. So that the 3 is aspirational. It doesn't always happen, but I'd say by and large, that's what you get. So.
And so, there's this incredible number of papers being submitted and reviewed every year. You just said that, you're getting requests to review these every single day. Can you give people a sense for how much of your professional time you spend reviewing papers as a peer reviewer? And who are you getting paid to do that by your university? Or is the journal actually paying you because you're doing it on their behalf?
Yeah. So that's a tricky question. So the answer, I again, right now, because I'm running a journal, I don't actually do a lot of time peer reviewing because I have other things to do. But I would say back when I wasn't doing that, I would probably peer review probably on average a paper a week, maybe a paper every week and a half or something like that. So something between 30 and 60 papers a year would be typical for the number of papers I would peer review. Part of that's probably more than typical, but not by much. And each of those papers probably takes, even if everything's smooth, it's hours of work to review a paper, to read it carefully, to construct, to write a review that's thoughtful and warrant, you don't want to send someone just a cursory, review of their work, or you want to show that you've read it and you want to do them right. And so, so the question of who's paying for that. So in very few cases, journals pay for that directly. So there's some fields where this happens, like economics, I think they pay reviewers nominal fee, but even if they paid a nominal fee, it would be less than than what I'm being paid for my time by the university, right? So it is considered a professional responsibility in the sense that I included on my CV that I review journals as part of my assessment by the university. And yeah, like in some sense, I'm being paid by the university to do this as part of my role as a scientist. It's not really explicit though, and this is something that that comes up a lot. Like oftentimes graduate students and postdocs are kind of looped into the review process by their professors. And, it's a good way of learning how to write papers is to help to review them. And so part of that's a training exercise, but it's also, they're definitely not being paid for it. So it's a very fuzzy thing in this industry, is like, because the industry, what do publishers actually do? Why do we need journals, right? So one big question that I think that I ask all the time is, why do we need journals at all? What do they do, right? They used to print things and mail them. We obviously don't need that anymore. We have the internet, right? Like you're going to post this video on YouTube. You're not going to make CDs and mail them to everybody who's interested in the video, right? So the mechanisms of dissemination have changed since the internet came along. And, so the actual physical dissemination of work is no longer really a thing. Mm-hmm. So what then did, if you distill out what journals do, they have two main functions, right? They oversee the peer review process, and they oversee a process of transforming whatever, poorly formatted document I sent them in the first place into something that looks pretty. That too is becoming more of an automated task. I mean, honestly, like it's mostly farmed out to companies that specialize in converting, trashy Word documents into pretty web content. And so the real thing that journals do is oversee peer review. And so you can ask the question, like, the scientific community is basically subsidizing that endeavor by paying the salaries of all the people who do the work. And so one of the big questions is just, what are the kind of terms of that relationship between the scientific community and the journals? What should science writ large and scientists individually expect to get back for the fact that they are actually the intellectually valuable work, the value add, as you would say in any industry, is the peer review, right? Mm-hmm. The content that comes in, if we just took the content that authors sent us and published them online, that would be a business. It would cost some money and whatever, but it would have the value add would be easy to quantify because it's just paying a XML chop shop to turn documents into web content, right? That's a commodity. The intellectual value added, which is, comes in two pieces. It comes in work changing and being improved notionally by having someone else read it, comment on it, point out where the flaws and shortcomings are, or even just where they didn't understand something to help them communicate their work better. So that's part of it. And the other part is this annotation that comes with putting it into a journal, which is, it's valuable to me as an author and valuable to the reader to know that this particular group of scientists thought this work was worthy of my time. How valuable it is and can we do it in a different way is another question. But those two pieces of value are based on information that's being provided by scientists in the vast majority of cases for free, or at least in a way where they're being paid for their time external to the industry. And so the fact that that's where the value comes from, and yet journal publishing is, an incredibly lucrative business, and it's complicated. So let me finish just for people describing the process, because I think it's worth knowing. After you get the peer reviews, usually the editor looks at them, and sometimes in consultation with the reviewers, and comes up with a decision. And the decisions aren't that complicated. Sometimes it's, hey, we love it, we'll publish it. It's rare for that to happen on first run through. Almost always the reviewers and the editor have something to say back. They'll say, yeah, well, it's great, except, this one experiment could be presented in a different way, or maybe you could do this other control, or did you think of this, blah, 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 blah. Usually, even when their judgment is favorable, there's some asks from the journal to the authors to modify the manuscript or modify the analysis, or in some kinds do more experiments.
Mm-hmm.
And you know, the more attractive the journal is to the authors, the more difficult it is to get in, the more the journal feels it can ask for things from the authors. So a very high impact journal feels in a pretty comfortable position to say that, yeah, this paper's fine, but if you did this experiment, this experiment, this experiment, now it would belong in our journal. The authors have an incentive to do that. And so at a journal that's more specialized, doesn't have the cachet, the motivation, the author's motivation to do that is lower. And so the asks are usually smaller. And so, you know, and then, you know, even the journals that have decided, you know, once they've decided to peer review a paper, they will often reject it because either flaws were found in the science. That's typically why flaws are found in the science that can't be easily addressed by a few additional experiments or analyses, or, you know, what looked like an interesting and important result didn't turn out to be because the data are believable, but the reviewers feel they don't really support the broader, bigger conclusions that the authors made. So that's would typically be why papers get rejected. And those rejected papers, we've looked many times at different journals, they almost all end up getting published somewhere.
Mm-hmm.
Because, you know, either because different reviewers see it in a different way, or because a different journal has different editorial kind of policies and goals. So, you know, there's a little bit of ping-ponging that takes place both back and forth at one journal, but also between other journals. And then, you know, then they get published, and that's where the 2 million number comes from. Every year, about 2 million papers get published in this big collection of 50,000 journals. And you can do the math and realize that most of these journals are obviously not publishing a huge number of papers, right? The average number of papers published for the average journal is less than one per year. So per week, I mean, and yeah, less than one per week. And so, you know, some publish a lot more, and so some publish fewer. So
Mm-hmm.
while there are 50,000 journals, it's a very long tail of
Mm-hmm.
of journals that don't publish a ton of content. So.
Okay, so just to sort of regurgitate some of that, you're a scientist, you're working in a lab somewhere, you've been funded through grant money, you've spent probably a few years doing work and crafting a story, you've submitted that to a journal, it's now taking months, potentially even longer than that, to go through the entire peer review process, depending on if you have to do more experiments or anything like that. And then it finally gets published. We've talked a little bit about the really, really large volume of papers that get published. And you mentioned two things that were interesting. One, the biggest value add for what's going on here is the intellectual work done in the peer review process. So the scientists reviewing the work of their peers. The journals have basically crowdsourced that, right? They're shipping that work out to all of the other scientists because that's what peer review is. You also mentioned that it's a very lucrative business. So where does that revenue come from?
Right. So this is kind of the elephant in the room here, which is that in the pre-internet era, journals, there was kind of a logic to the way this industry worked, in that you know, it costs money to print and mail a journal around the world. And so since the costs largely scaled with the number of copies you produce, not entirely, there's fixed costs involved in peer review and things like that, but you know, a large fraction of the costs at least were scaled with copies of the paper sent. And the standard business model was a subscription one, where if you wanted this content, you would subscribe to the journal. And that was in many journals done by individuals. Like, even I'm just old enough that at the beginning of my career, like we're getting print journals. And so for some period of time, I subscribed to the print journals I like the most. Like, you know, I subscribed to the journal Genetics because I love it until long after I could get it online, just because I like getting a tactile physical version. So most scientists would subscribe to a few journals, usually through a scientific society. But then the bulk of that, you know, that started to become less and less efficient over time. And so the bulk of that subscription kind of revenue was coming from libraries. So libraries took over the task of providing access to journals, especially the ones that people didn't read on a daily basis. Like, most scientists still, I think, get Science, Nature, individual subscriptions to them to read the science, and because they also have a news section that they like. And then, I don't know how many people still get print issues of other things, probably fewer. But back sort of when I was starting, typical scientists would get, 4 or 5 subscriptions to 4 or 5 journals that would be in their office, the kind of things that they looked at all the time. But obviously, I will, when I'm doing a research project, I will be drawing on work that's published in dozens of journals. Mm-hmm. And so it's not practical for me to subscribe to every journal for every field I'm interested in. And so that work over time got shunted over to the libraries, who are obvious natural places to do this. And the industry developed a kind of business model where libraries paid more and more for their subscriptions because the institutions knew they were sharing them with larger and larger number of people. So it's typical to have it used to be typical to be much cheaper to subscribe to a journal as an individual than as an institution. So increasingly, the publishers started to see the libraries as their customers. And they, but because there were there are fewer libraries than there are scientists, they had to start charging more and more because the libraries were the, their sole, not their sole, but probably their predominant source of income. And that started to become a problem even before the internet came along. It started to be a major economic strain on libraries to subscribe to journals, especially because as printing got cheaper, more journals were born because the journals saw in university libraries especially especially big research libraries have a mission, their scientists want, if I'm starting to do a project and my project is on, the snails of Bolivia, I want the Bolivian, malacology journal, right? And so scientists came to expect, especially at big research universities, that the library would have everything. Mm-hmm. And so the industry started to get a little out of whack even as early as the 60s when there was, journals were born essentially to cater to the library market instead of individual scientists. Mm-hmm. And part of the reason the journal industry has grown so big is because of the centralized kind of purchasing of subscriptions.
So is it fair to say, so when you say that libraries are the primary customer, you're typically referring to a university library?
Yeah.
So you go to university, whether you're a scientist or just an undergrad or whatever, you have access to all of this knowledge now through the university. Right. The university's paying essentially for a bundle of journals, the same way that bundling is so common just in our ordinary lives now. You buy bundles.
Yeah, the bundling is a relatively new innovation in that industry. It came kind of late to the field, but yes, that's what they do now. Right. And it's okay. So it's useful to draw a line in the sand here between before and after the internet, right? So as even before the internet came along, there were big cracks in this model because there were too many journals. They were charging higher and higher prices. Their primary customer was not really operating in a free market because, the University of California Library felt a responsibility to subscribe to every journal out there. And if they canceled a journal, they ran the risk of some professor who in general is in a more prominent position within the university than the librarian, complaining that I can't believe they canceled their subscription to this journal. And so there was a lot of pressure on universities to subscribe to everything, a situation that publishers took advantage of. They took advantage of it to spawn new journals and to increase their prices. And, since the 60s, the cost of science journals has been going up at a rate greater than inflation. It's been very consistent. It seemed like, right? So, but importantly, at its core, there was still a logic to the system, right? You were still disseminating things in print. You still needed to buy access to a physical copy, even if they were charging too much for it. It at least that you had to do something like that. It made sense to send copies of every scientific paper to every library. And this was a mechanism to do it, even if it wasn't the most economically sane and efficient one. But as soon as the internet came along, all of the logic of that just completely evaporated, right? It stopped being expensive to send an extra copy to anybody, right? It's, the marginal cost of downloading a PDF of a paper is close to zero. And but because the publishers were operating in this incredibly lucrative business environment where their profit margins were extreme. Even before the internet came along, they were profiting. The big publishers, there was a lot of consolidation in the industry. Smaller journals got bought up by big publishers who, again, went to the universities with these big deals and said, we'll give you a 75% discount on every one of our titles if you buy them all at once, which of course is great for the publishers because they get this huge check. It encourages them to buy more journals because now they can justify a higher price.
So but it's not just a bunch of individual academic societies with their journal. It's large publishers that are creating bigger and bigger libraries of journals, and then
that's right,
the whole thing.
And pay. They would in fact in many cases just say, we'll take over your journal and we'll cut you a check every month or year for something. And the society now had a guaranteed revenue stream and no expenses because it was a great deal for the societies. Like it was good for everybody except science. And the reason it wasn't good for science was when the internet came along, and we should have there should have instantly been a YouTube for science, right? Where I have a paper, I post that paper, and anything that happens subsequent to it, especially because most of the work's being done by scientists, anything that happens subsequent to it is happens in the open and is paid for by science, right? The libraries could have taken their subscription budgets and thrown them out the window and paid for all these costs easily. There was more than enough money. But that didn't happen. And that didn't happen because in the meantime, it became true that your worth as a scientist was measured in the journals that you published in. And so the publishers could basically just dictate whatever terms they wanted to science, because the individual scientists weren't going to change things because they felt their careers. I mean, you could quibble with whether or not this is true, but they certainly feel that their careers are dependent on publishing in the right journals. And so the journals have no incentive to change anything. Scientists are still sending them their papers. And now the journals can say, yeah, sure, we don't have to mail you a copy of the journal anymore, but you still have to pay. And if you don't pay, you don't get access. And so the journals were like pioneers in paywalls. They were within months of the birth of the modern internet, the first modern paywalls were erected by science publishers trying to continue a subscription model in a world where the technology, it no longer made sense. And so I always like to joke that if the internet had been invented before the printing press, right? Right. It sounds crazy, but there's a real particular reason why that, you can imagine alternative histories where digital technology takes off before print. And you would not have invented the system this way. You would have invented a system where there's a common central place where people post all their work and it gets peer reviewed on top of that. The logic of there became a huge mismatch between the economic model and the structure of the industry and the technology of the moment. It's as anachronistic as anything around, and it's fueled in part by profit motive of the publishers who make tons of money, but it's really fueled by the fact that scientists, we basically continue to judge scientists,
where they publish.
Yeah, we judge them in 2021 in exactly the same way we judged them in 1994, and that the internet has had, close to zero impact on that. So,
yeah, there's a screenshot that people love to share on social media where there's some article written in one of the big journals titled something like "The Growing Inaccessibility of Science," and then it's behind a paywall.
Yeah, of course. It happens all the time. There's not just one such thing, right? So it's like that's the way it works, and it's nuts. Like it really doesn't have to be that way, and I think that's the critical that's the critical thing. Like we have, so just so people understand, this is a huge industry. Revenue for science publishing is in excess of $10 billion a year. That's more than $5,000 per paper that they publish. And their profit margins are as good, they would make Apple jealous. Like if you look at the list of the most profitable corporations, it's, software companies and science publishers dominate, because
who are the big publishers, just so people have a sense of the entity?
Yeah, I mean, the biggest is Elsevier, who is a Dutch publisher who has been around in some form for many centuries, and they were innovators in this buy up other journals and sell big packages to universities, which helped them grow. They're also a big book publisher, as often is the case with these science publishers. They are the biggest by far of the publishers. The next two are Wiley, and then Springer, who also owns Nature. So Springer Nature. Those are the big companies. There still are a fairly large number of independent societies that operate their own journals. So Science, so Nature is obviously owned by Springer Nature. Cell is owned by Elsevier. It was not started by Elsevier, but was started by an individual scientist who then sold it to Elsevier. And Science is still operated by the American Academy for the Advancement of Science, or American Association for the Advancement of Science. And they are a not-for-profit, but you would be hard-pressed to tell that from their business practices, because they look, they function, the society is funded in large part by selling subscriptions to science. So it's, there still are nonprofits, but it's a shrinking part of the industry. And really these commercial players dominate. We know this at UC. UC had drawn a little bit of a line in the sand against Elsevier. Unfortunately, they retreated back across it recently, but they had refused to pay Elsevier's demand. So for about 18 months, we didn't have access to Elsevier journals, didn't have legal access to Elsevier journals. And you notice there's a lot, they publish a lot of stuff. That's the point. Like, day-to-day, it's a day-to-day actions of science. You probably touch all three of those big publishers.
Okay,
in one way or another.
Let me try and summarize some of the key points here that we've touched on so far. You've got this big legacy industry, which for historical reasons has come to take the shape that it has. You've got these big publishers that have sort of corralled a bunch of journals together so that they could sell access to all of that information to universities. And by virtue of its nature, a university wants to provide all of that information to its students and its faculty and so forth. So you've got kind of a captive audience, which allows these publishers to have the business models that they have.
Yes.
The peer review process itself, the single, arguably most valuable part of getting something from written in a Word document to published out in the world, is done by scientists for other scientists. That's what peer review is. That's quasi paid for maybe by the universities because it's supposed to be part of your job, but it's this duty-driven thing that everyone feels rightly an obligation to do. So one of the biggest single expenses for a journal, in theory, is actually not there, because they don't actually have to pay someone to do that work. And that's why, in part, their profit margins are so high. Their expenses are not arguably where they should be.
That's right. It's just like, a professional football team if someone else paid for all the athletes. Like, let's say the NCAA is a good example, right? The NCAA is probably a perfect example of like an organization that effectively exploits free labor. At least we can say that peer reviewers in science journals don't get concussions and knee injuries and stuff. But it's the same model, right? If the actual vast majority of your labor is free, and you have a customer base that will pay huge amounts of money for your product, you're running a pretty darn good business. I think in business school, like if you came to them with a case study that says, hey, I'm going to start a business where we're not going to pay anybody for the stuff we're buying, but we're going to have a fixed captive market that will absorb ever escalating prices to pay for our product, they would fail you because it's ridiculous. Right? But of course, it's a function that is what this industry is. And, I should be clear, I don't blame the people who run these companies for operating this way, right? It's science's fault that it exists. We could change it tomorrow if we wanted to. Like, there's nothing essential. They provide no essential activity other than organizing peer review, which is something that, could be reconstructed relatively easily from the ashes of the publishing industry. So it exists. It would go away entirely if we didn't have this like linkage between careers and journal titles. So
yeah, and I want to talk about that next. I can just tell people from my own experience when I was a graduate student, like, no one would walk around and say explicitly, usually, I only want to publish in Nature and Cell because they're the best. Like, but you kind of like, but people did.
It's like they don't say it because you don't have to say it, right? Like, that's part of the problem. Is it's so kind of embedded in the system, right? It's just like that. Like it's not that they don't think it; it's that you don't even have to say it because everybody just assumes it.
Yeah. Yeah, absolutely. So people truly believe that, the Nature and the Cell paper is a better indicator of your quality as a scientist. Now, one of the natural questions here is it? So is it in the sense that people get hired to better positions at top tier universities if they have those publications, or is that an illusion to some extent?
Yeah, I mean, so I think it's really important to differentiate between different places here. There are parts of the world, in some countries in Europe, some countries in Asia in particular, where it literally is true. Like, you get a score, and the score is based on where you publish, and each journal has a value attached to it. Sometimes it is literally this impact factor. So people, like, we've used this term before, so just to tell people what it is, the impact factor of a journal is a really easy thing to understand. It is the number of times, the impact factor for a journal in 2020 is the number of times the papers it published in 2018 and 2019 were cited in 2020. It's just like a direct ratio of its citations divided by the number of papers it published. So it's a very crude way of characterizing the influence of the journal, right? It basically says, if you publish a lot of papers that everybody cites, you get a higher score. In some parts of the world, that score is directly used. If you get, I forget, I try to avoid knowing about impact factors, but it's hard to avoid because sometimes they send you solicitations with their impact factor calculated to 4 decimal places. So let's say, a journal like Nature is probably in the 30s. And that means that the average paper is cited 30 times in the, I think I got the formula wrong. It's like year X citations in the following 2 years or something. I don't even care enough.
But it's formula. A number. It's related to how often you're going to get cited.
Right. And it is used just to calculate your value as a scientist. Okay. Now the US by and large does not do that explicitly. So, here the journal influence is less direct, but in some ways more insidious, because it isn't clear what you have to do to achieve the goals of the system. It is certainly the case that if you were to look at jobs at, say, the top 100 research universities, who's getting faculty jobs at those places, they are highly enriched for people who publish in these top impact factor journals, and not just Science, Nature, and Cell, but also their spawn. There's Cell and Nature in particular have spawned sub journals for the papers that get rejected from the parent journal and so forth. And so there's a lot of that going around. And so it is certainly true that there is a correlation. I think it is probably also true that all things being equal between two scientists, like if they literally had exactly the same profile at whatever people were looking for, the same field, the same stuff, that the person who got their paper into a high impact journal and compared to a person who didn't would benefit. However, I think the extent to which other factors play a role in this is underappreciated, in the sense that, it is also true that the people who are getting those jobs in those top 100 universities trained, did their postdocs at, 20 places, right? Like people who do their postdocs at Harvard, MIT, Columbia, Berkeley, University of Michigan, University of Wisconsin, with UCLA, University of Washington, right? There's a list of like, biggest, well-funded, most prominent research universities, and their trainees tend to get the jobs at most other places, even at bigger their trainees get jobs at a bigger footprint than those universities have. So that has a huge influence. The field you work in has a huge influence. Your results themselves have a huge influence, right? Like the fact that it got into a high impact journal isn't an accident. It reflects that the community as a whole likes that work. Whether they're right or wrong sort of doesn't matter. There is the same standards are being applied kind of not uniformly, but fairly regularly across the field. So I think it's certainly true that like the type of science that tends to get you a job at a top university, and the type of academic pedigree that gets you that job, is the same science and pedigree that gets you papers in these high impact journals. So it is one indicator of success within this system. The idea that, however, that if you got rid of that indicator, that the system wouldn't fundamentally perpetuate as it is probably false too, in the sense that like, if universities were forced to stop looking at journals as their, in their faculty evaluations, let's just say we passed a ballot initiative in California that said that you could not look at journal titles when you were evaluating candidates for faculty positions. We probably wouldn't change our hiring all that much, because the other things come into just hold a little bit more sway. And since they're all highly correlated, you end up making the same decision. So that's both good and bad. To me, that means, in the good sense, it means that we could get rid of the system without destroying science. Like we could save $10 billion a year, do something, right? And we didn't talk about it, but let's like one of the big problems of that whole financial structure is that very few people on Earth have access to all the scientific papers, right? Like if only libraries are subscribing to these journals, then only people affiliated with universities whose libraries are doing that, which usually means rich universities in the developed world, basically, even within the US. Like for a while, my mom was a teacher at George Washington University in DC. It's hardly a tiny wallflower place, but there were lots of papers she didn't have access to because their library couldn't afford it, whereas UC's could. So so a major problem with the current system is it costs $10 billion, and we don't even buy access for the whole world with that $10 billion. We buy access for just a few tiny fraction of even scientists at elite universities, not to mention like basically no teachers have access to research articles. Few physicians do. Patients, when they're trying to research a disease or something, don't. So there's a huge inefficiency in the industry. We could get rid of it tomorrow, right? It's unnecessary for the functioning of science. We could get rid of it tomorrow, and we would be able to replace it with something better that would be cheaper and fair, whatever. Some people think that have an idealistic view that you get rid of the journals, you've solved the problem. It's a little bit Hydra-like though, in the sense that journals are a problem. Journal access is a problem. Journal structure is a problem. The inefficiencies of peer review are a problem. But they don't it's both a good and a bad side that they don't immediately solve all the other problems that exist in science, because those are more deeply entrenched than just journals.
So I want to talk about open access journals and what you're doing at eLife, for example. So just to sum up part of this, it sounds like in theory, there's journals like the ones we've described that are behind paywalls. There's also these things called open access journals that we'll talk about. And if all scientists tomorrow just decided we don't want to play within the system we've been playing in, we're all just going to publish to open access journals, effectively nothing would change in terms of the science being produced, and you could get things out from behind paywalls.
Yeah.
But for sociological reasons, people do not choose to do that.
Correct. So, this is precisely that insight was what drove us to start sort of open access in the first place, which was the internet came along. Honestly, up to that point, I hadn't even bothered to think about journal like access. It was just like I went to I was a graduate student at Harvard. I had access to everything I ever wanted and a lot of stuff I'd never thought about, right? And didn't care about, right? Like the university was paying for me to have that privilege. And so I started my postdoc, coincidentally, right at the dawn of the modern internet. And I did it out in California at Stanford, where internet was dominating the way that everybody was thinking. And it just sort of became quickly obvious to, initially my advisor, Pat, was sort of the first one to kind of really start railing about this, but just how dumb it was that journals were not taking advantage of this technology to make their contents free. Like in a very literal sense, the internet was invented to help scientists communicate, right? Like those early nodes you've seen sometimes of pictures of the early wiring of the ARPANET, that whole purpose was to help scientists. Now, they were defense scientists working on defense science things, so it wasn't meant to be shared with the public, but it was meant to help them communicate with each other. And a lot of the early technological development in the internet was explicitly about university to university communication to allow scientists to share information with each other. So for the actual public internet to come along and have one of the first things that happened on it was, the organizations who had been entrusted with control over the scientific literature, publishers, to use the internet to perpetuate the access problems of the previous technology was just nuts. And so, after, our initial view was that we should just tear the whole system down. Don't even try to think of a new way to fund it. Just start from scratch. And, ironically, the physicists had already been doing this. Physics since the early 90s, before the modern internet came along, had this thing called they had a preprint server called arXiv. It actually originally was called xxx.lanl.gov. That was their first website, which obviously, as the true modern internet came along, had to change its name. But the X in their original, right? It's kind of a funny story. The physicist who invented it, Paul Ginsparg, physicists had been mailing copies of their papers to each other, their preprints, not their published journal papers. They had been mailing papers to each other, not to everybody, but to all the, colleagues at prominent places that they cared about. You can talk about the unfairness of that system if you want to, but like they would mail papers to people they thought would be interested in reading them or that they wanted to read them. And every physicist would have like a, cabinet of papers that their colleagues mailed to them that was basically their library of papers. That was just an informal network of shared preprints that your colleagues were sharing. So along come the early internet, the pre-public internet, the one that mostly we had access to at universities in the late 80s and 90s. And they just said, well, why do this by mailing physical copies? You have an electronic copy on your computer, just mail it to your friends. Okay, so they started doing that. And then someone said, why mail it to your friends? Just post it in this common server. So Paul Ginsparg, who was at Los Alamos at the time, just created a site, which again, there was already a www.lanl.gov. So this was xxx.lanl.gov, lexicographically next. And they just did it, and they continue to do it. The physicists just post their papers on arXiv to this day, and you can get them for free and read them, and it's totally fine. They have not collapsed as a society. So we felt in biomedicine, which is much bigger, much more expensive journals and so forth, we should just do the same. And we convinced the NIH that they should do it, the big funding agency who's got lots of money to do these kind of things, and has a library, the National Library of Medicine, whose mission is to make scientific knowledge available to the public. You can, if you happen to be in Bethesda, Maryland, which is where I grew up, so I know about this, you can just go into the National Library of Medicine and get any journal you ever want, read it for free and whatever. So they have that mission. We felt it was just an obvious continuation of that mission to do that electronically. The NIH put forward a proposal to do that, and it was killed by publishers, scientific societies, and publishers. This is in the late 1990s.
How did they kill it?
The standard way you kill things if you are in a position of power, you get your congressperson to say that they will not fund this, right? So the NIH, who is obviously dependent on annual budgets from Congress, was told, you can't do that. We will strip your funding for that, not the whole funding, but we will not fund this activity. You have to do something.
Presumably the big publishers used the money that they have to pay lobbyists for
not presumably. They did. There's a paper trail of this. So they paid lobbyists and they lobbied themselves. And, part of the problem is, one of the reasons we're kind of stuck in this world is that the scientific societies are viewed by Congress as representing science. And in most cases, they do a good job. Like, they're good at advocating for funding. They're very strong on promoting the use of science in public policy. It's not like they can be very good and useful voices for science. Unfortunately, their revenue stream is built on subscription journals. And so when this policy got put forward, these scientific societies, who had a lot of credibility in Congress speaking for science, went to them and said, no, this is terrible. It will kill us, right? And it was implied that killing scientific societies would be bad for science, which is, I don't think, the case. But so they were effective in convincing Congress that this proposal would be disastrous, and so it didn't happen. And what instead, instead we tried to figure out a way to accomplish the goal of removing paywalls to scientific journals that didn't require government action. And so what we did instead was kind of, not just us, there were other startups and people in the industry kind of latched on to this model, which is to say that let's stop treating scientific knowledge as something you own, right? Right now, the reason journals can sell papers is that the authors assign them copyright. They assign them copyright as a part of the process of publishing your paper. I used to do that too, because what do I care about copyright? I'm not going to sell my work. I might as well give it to the journal. It's fine, right? That's true before the internet comes along, because I had no use for the copyright. Nobody else did either. Like, no one else was going to produce a version of Nature that they would print themselves and mail to everybody. It just didn't make sense. Internet comes along, traditions continued. You're still assigning copyright to those publishers, but now they're using it to restrict who can get access to their content, which is obviously what copyright gets used for on the internet. And so our view was, well, let's not have a model that's based on journals making money, recovering their costs and whatever by taking ownership of the content and selling it back to interested parties. Let's have a model where you just, whatever expenses the journal incurs in the process of producing an article, let's just pay them those expenses and a profit, whatever we think the sensible business is. And in exchange for paying them up front, they don't own the content, the public does. So it's a service. It's transforming it from a content model into a service model. And the obvious benefit is that there's no longer any paywalls, that the scientific literature could be free. And lots of arguments from us, but also lots of studies from people have said, in addition, it's a more efficient market. It'll be cheaper. Whether that's true or not, it sort of doesn't matter. Even if you just took the $10 billion we spent today and just continued to pay all the publishers, but you did it under open access, a different agreement, a different way of transferring the funds, they would keep all their money, but all the content would be free. It's such a frustrating inefficiency in the world that there is a path here where everybody gets what they want, right? The publishers can still get paid, the public can get access to the content, authors can still publish in journals. And just like our inability to bridge the kind of incentives that exist in each of those communities to get people to actually do the right thing collectively. But that's what open access is. Open access is a model where publishers say, we'll publish your work. It costs us some money we have to have staff who deal with peer review and find the peer reviewers and convert the papers. It's a very heavy touch kind of process. So it costs some money, but you pay us when you publish a paper. And then we don't own it. You do, or the public does. And, in exchange for this work we're doing, all we ask is that you license your work to the public domain and let people use it for free. And so I started a publisher called PLOS, Public Library of Science, which still exists and is a big publisher in the field that was instantiating this open access model, along with now a publisher that's been folded into the Springer universe called Biomed Central, which was also kind of trying to develop and promote this open access model. eLife, the journal I run now, is another open access journal who's trying to do other things, like we're trying to go beyond to the next step of reform in publishing, which is rethinking how peer review happens. But
yeah, I did want to talk about that. So the actual peer review process, what are, if any, the major problems with how that is typically conducted today in terms of like conflicts of interest that different scientists might have?
Yeah, so that's certainly a problem. I mean, I think it's a tricky business if you think about it, that like the ideal person to review a paper is someone who's doing exactly the same experiments, right? And so a lot of scientists, I'd say the vast majority of scientists, are able to dissociate their, largely everybody's got hidden biases in these things. So I don't want to pretend anybody can ever be unbiased in this way. But like, I think the vast majority of scientists are able to, largely act as fair and reviewers of even their competitors' work, because, it's just like, you don't go into this business mostly to be a jerk. So, I would say that by and large, that part of the process is okay. Like that people review things fairly. I obviously we can do a better job because there's always conflicts of interest and they're not always clear. And part of there is this weird, this lack of transparency in the system is problematic. And it's hard. It's a tricky thing to overcome, because forcing people to identify themselves, for example, in peer review, it tends to exclude people who are in marginalized positions within the field. Like the only people who feel really comfortable trashing their colleagues' work are people who have tenured positions, right? So there's some problems, but I would say that actually isn't the big problem here. Like I think peer review is biased, but the real problem is, given that there are aspects of peer review that are biased, and I'd say even more problematic, that even when everybody is operating completely in good faith, even when the right people in terms of expertise and knowledge and breadth of thinking are chosen to peer review a paper, even when they do that work diligently, they read the paper carefully, they don't just do it in the last 2 hours of some flight where they're about to fall asleep, which is often what happens. They do it diligently and they do it fairly and honestly and constructively. Their decision, their judgment, is being reduced to a binary assessment of the value of the work that lives with that work forever, both good and bad, right? So I would say the biggest problem in peer review is that it happens only once at one fixed point in time by a small prescribed group of people, and that it isn't a problem that they do it. I think, right, peer review is very valuable. The peer reviewers spend a lot of time doing things. That's a good thing. It's a good thing when someone reads their colleague's work and comments on it. The problem is that we greatly, 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 greatly overvalue that decision, or in particular, the way the decision is rendered, such that a paper that was published in Nature and 6 months later is generally thought by the community to be wrong, not not bad, not that they did the experiments bad or something, just that the conclusions are wrong or that it wasn't as interesting as they thought it was or whatever. Like everything's on the up and up. Nobody cheated, nobody missed something. It just quite often things that seemed really important are quickly realized to be unimportant. That paper remains a Nature paper forever because the assessment at that one moment was that it belonged in Nature. Conversely, you see this all the time when people like make really big discoveries or win Nobel Prizes or something. Like if you look at CRISPR, right, like the coolest biological innovation in the last decade, like the history of CRISPR is littered with papers whose significance was missed by the people reviewing them. And so those papers published in, yogurt journals and, like literally like a lot of that work came out of Dannon and, like a lot of really, really, really important science, its significance, it's not even that it was missed. It's just, it wasn't apparent at the time. And so it forever, those papers remain obscure. And, if you look, like CRISPR is a good example, I have nothing but immense amount of respect for my colleague, Jennifer Doudna at Berkeley and Emmanuelle Charpentier, with whom she won the Nobel Prize for this. But there were other scientists whose work kind of suffered in peer review that probably would have been credited with discovering CRISPR had the world gone a publishing function a different way. And that's bad. I mean, it's no discredit to the people whose work has been instrumental in getting this to the forefront. But I do think that we just, it's this historical legacy of the fact that you had to make a decision. If you were going to print a journal, you had to make a decision at the time you were choosing to print the journal of what's in and what's out, right? That was a sensible decision to make. We continue to render it now as a decision long after it's stopped making sense. I mean, there's literally no reason for us to attach a single permanent mark on every paper and not revisit it, right? We don't revisit it. We don't let other people participate, right? Like why, if a paper is so important, surely if a paper really is so important that it warrants like going into like being one of the handful of papers that appears in the elite journals every year, surely other people can review it too and see if they come up with the same conclusion, right? Like this, and again, it's not the journal's fault, it's our fault for only valuing that, right? If I started publishing a list of papers that were published in Nature and shown to be wrong a year later, no one would care because the authors of that paper have a Nature paper and it's on their CV. And the fact that Mike's list of bad Nature papers includes their paper, they're not going to care. Similarly, if I said, hey, here's 20 papers from 2015 that were missed and you should pay attention to them. I might make a good Twitter stream, but it won't show up on people's CVs and it won't affect their career path in the right way. So it's that, I would say, more than anything, that this fact that we only do peer review once, we do it on a small scale, we don't come back and revisit it, which is not like an important paper that's published in Nature, right, is probably read by thousands of people. A large fraction of those people spend enough time thinking about it that they have views of the paper that would be worth sharing with the community. We have no way of capturing that. We have no way of rendering that. You see quite sometimes a paper has been published for minutes and people realize it's wrong because they find fatal flaws in it that were missed in peer review. It doesn't matter. And it doesn't matter because all the value is placed on the journal title. And that's the kind of core problem that needs to be fixed in my mind.
How often are the peer reviews published alongside with papers that get accepted?
That's growing. So eLife, which is the journal I am editor-in-chief of now, it was founded on this idea of being much more transparent about peer review by Randy Sheckman, who was the person who founded it, kind of really was, pushed this notion that we're not on the internet, like it's not wasting ink space to publish the peer reviews. So the peer reviews in eLife are published, but only for papers that are ultimately accepted. And they are available. If you go to any eLife paper, you can actually see the peer reviews. And actually, students find them very valuable because it's kind of an insight into the process. They're not really used that much, though. Again, it's like kind of an irony that eLife, which was founded as a journal to try to avoid using journal titles as a way of indicating things, has now become a journal title that people use to indicate things. And I think part of the way you can tell that is that nobody really cares what the reviewer says. Like once it's in eLife, either because they feel like they can judge the paper themselves or because all they care about is that it was an eLife paper. By and large, those aren't looked at. This is something we're trying to change now. Like I think, part of the problem is there is not a lot of visibility attached to peer review. And also part of the problem is it's usually published after the paper has already been published, when it serves much more of and I think an important role, but it serves more a role in transparency than in they're not written to be used in a way. So we've kind of implemented a new policy at eLife recently in which, first of all, we should come back to the preprint thing. Finally, biologists are using preprints. Took 20 years, but the system that was killed by publishers has now started to take off. And I would say, we're definitely on the right part of the trajectory in terms of preprint adoption. That it's easy to imagine a world where all papers are posted as preprints first.
Even though we already talked about it somewhat, can you just define for those who are unfamiliar, what is a preprint?
So preprint, a preprint is a paper that the authors share prior to peer review. Is the easiest way to think about it. That it's a manuscript that the authors have written that they feel is worthy of sharing, and it's something that they post. There is now a place you can post those. Many places, but field specific places. But if you're a biologist working in sort of any area of biology, you can post your paper on bioRxiv, and it's a very low touch process. I have a PDF of my paper, I submit it, they look at it basically to make sure that it is a legitimate work of science, that it's not just an opinion piece, it's not porn, it's not really crank science, and it's not dangerous. It's like you can't publish a recipe to synthesize COVID in your basement or something. Mm-hmm. And so I can post something there, and usually within 24 hours it's up. And then everybody can access it. It's completely free. You can download the contents and use them. But they're unpeer reviewed. And so, authors, you're basically either going on your own judgment of the work, or you're relying on the authors as a credibility to know that it's at least it's good. So there's a little bit of a buyer beware kind of attitude around preprints. Although I should also say that same buyer beware attitude should exist around peer reviewed papers, because peer review is only 3 people. It's not perfection. So preprints exist. A lot of scientists are posting preprints. They're visible. There's no, anybody can look at them. There are a lot of Twitter activity around preprints. A lot of scientists are now primarily using preprints as their means of communication, reading papers. And certainly we post preprints of everything we publish, and a lot of scientists are doing that. So what we're trying to do now at eLife is to just actually start reviewing preprints, to say, all right, if preprints take off, we've solved the access problem. We've solved it not by converting existing publishers to an open access model, but by just having everybody share their work for free on a preprint server. Okay, so that's one thing. The second thing is, if you start to attach reviews to preprints instead of publishing papers in your journal and claiming that's a final act, now you can get past this problem of peer review being a static object. So if eLife peer reviews a paper on bioRxiv and posts the results of our assessment, and some other journal or some other scientist wants to come along and review that paper, they can do so too. And the community can make their own judgment of which of these assessments is more valid, or the assessments can even talk to each other at some level, that we can start to develop a little bit more of a robust culture of assessment around preprints. It's not without its potential problems. Like, we don't want, science to become any more of a popularity contest than it already is. It's, the downside of public commenting on the internet is well known to the universe. And so it needs some level of it needs to be run by grownups, or at least by probably run by responsible kids is probably the best way to do it. So it's not a trivial system to create and to think about, but it's definitely I think would be better. And so, because journals by and large are where peer review takes place, and because journals have a financial incentive to just keep publishing, either as open access journals because they're making their money that way, or as subscription journals, there hasn't been as much activity around reviewing preprints as I think there should have been. So we're trying to take advantage of our position to do that.
Mm-hmm. So one of the big lessons of the internet for me in my lifetime has been that when someone in some position of power or some power structure locks the front door to something, technology will eventually be used to get in through the back door or the side door. And so you told the story earlier of how some of the big publishers used lobbying to lock the front door, so to speak, and maintain their dominance. One of the things I want to talk about there related to that is this new thing called Sci-Hub. So what is Sci-Hub? How does it work? And how have journals and universities been responding to it?
Yeah, so Sci-Hub, it's really simple. It's a bunch of computer programmers who got frustrated with their inability to access the scientific literature. They were in Eastern Europe where these access problems are huge, right? I think, the countries and the research universities in Eastern Europe are probably in the worst position of all, because they're not small enough to be, they're not poor. The countries aren't poor enough and the universities aren't small enough to qualify for free subscriptions, right? So they don't get free access to journals. Like, if you're in a really poor country where the publishers have no hope of ever generating revenue, they unlock their firewalls because it costs them nothing, or their paywalls. But if you're in Kazakhstan or Ukraine or wherever these people were, they're not always entirely forthcoming about this, which is good for them. You want to do science, like, you just don't have access to the stuff. Like, it's just almost impossible, right? It's impossible to be a functioning scientist in a country or a university situation where you don't have access to the literature. It's like literally cripples not just your ability to do science, but by definition, it cripples science, right? Like if you believe in science as a thing that makes society go better, you have to believe that the scientists everywhere in the world who are not able to get access to the scientific literature, and therefore doing either worse or less effective or slower science, that's hurting us all. So the people behind Sci-Hub face this problem, and being adept at using the internet to obtain content, They got, by unclear means, the access to the universities that had access to all of this content and downloaded it. Not entirely clear how or what means they used to obtain it. It's presumably not legal, but that's between them and their gods. And made it available. You can go to Sci-Hub, which is unfortunately at an ever-moving URL because the forces of darkness catch up to them. But if you go to Sci-Hub and you've found a paper that you want to read, Sci-Hub isn't great for searching the literature. It's great for if I find a paper through some other means, Google or PubMed or something, that I can't get access to, I can just go to Sci-Hub and get it. And I'll admit, like, I've used Sci-Hub all the time for doing science when my access to Elsevier content was blocked by the access screen. So it's great. It's probably not a long-term solution because the publishers, when it just existed on the margins of the internet and nobody would go to it because it was in Cyrillic and they were afraid that they were going to get viruses or whatever, it didn't really cause a threat to the publishers. But I think one of the reasons why the Elsevier thing with UC was less of a big deal for UC scientists was that we could get content on Sci-Hub. And I think the publishers have started to realize that it's a threat, and they have used the fact that some of its practices are do not conform to current copyright law to get it blocked. You know, they have two strategies: one, to prevent them from getting access to the content they need to perpetuate it, which they seem actually to have done effectively recently. So it's harder and harder to get recent content on Sci-Hub because they've sort of made it more difficult. And second, they've blocked, like there are some countries where you just can't get, like the internet they blocked access to Sci-Hub by internet block. So yeah.
So you mentioned that you've used Sci-Hub, other scientists have used Sci-Hub. Is this common? And if someone out there, just a regular citizen, is using Sci-Hub, are they doing anything legally wrong that they can get in trouble for?
I'm not a lawyer, so I'm not going to give anybody legal advice, but I think the answer is, you know, it's complicated, you know. So I have talked to lawyers who will, you know, can come up with a legal framework for why using Sci-Hub is legal. But, you know, I think we know, like, you don't have to look very far on the internet to know if you get if you get access to pirated content, you are participating in piracy. So I think it is probably true that it is illegal to both. It's certainly illegal to take the content and make it available, and it's presumably illegal to get that content, although there are some exceptions under fair use that some lawyers will argue apply here. Also, it's not exactly clear who has to initiate that legal action, right? Like there has to be a copyright complaint. It can't just be like the police can't just arrest you for using someone else's copyrighted content unless they have a complaint that you're using illegal. I don't know. I'm not a lawyer. Don't take any of this advice as legal advice. But like, look, this is the problem with Sci-Hub is it exists in even its best manifestation on dubious legal footing, and I think it is on 100% solid moral footing. I think there is absolutely nothing wrong with Sci-Hub. The publishing industry is what's wrong, and Sci-Hub is it's like trying to fix a major, not just a theoretical problem, it's an actual problem for the world that science is being impeded by journal paywalls. So I think Sci-Hub, I love it, completely righteous thing to do, but I think it'd be a mistake for us in the scientific community to think we can rely on it forever, because its legal status is such that it is, you know, it's just one effective legal maneuver away from being inaccessible to everybody. And so I think, I hope that it has not created a sense of complacency among scientists that this backdoor will always be there for us to get access to content. And so I think it is important that the scientific community recognize that anybody who's used Sci-Hub should just demand that we should take advantage of what the internet was invented for and make Sci-Hub legal, right? Like Sci-Hub should exist. There should be a place where you can go to download every paper ever written for free. The fact that it is illegal is our fault. It's a pathology of science. It should exist, and it could exist. Since the internet came along, science publishing has received revenues of in excess of $200 billion. Just right. That's just publishing. That's not doing the science. That's just $200 billion to publish articles where almost all the labor was done for free by the community. It's like, can't you imagine that we could have invented and paid for and sustained a better system? Think about if we had just invested that $200 billion in an endowment for science publishing, we'd be fine. We would have like huge revenue every year that would cover the costs of of everything we ever have to do in science publishing. So it's really, Sci-Hub should exist. It should be immortalized as a legal dream. And that's my dream. I mean, honestly, like day one, when I was involved in this publishing stuff, like literally like 1997, we had a meeting with people at the Stanford libraries where we asked for some of the content they had on they had a publishing operation, internet publishing operation within the Stanford libraries. And we wanted to use their content in our research, not publish it, just use it in our research. They said no. And that kind of triggered a lot of our work, at least in open access. Almost the first thing we thought about doing was kind of creating kind of like Napster for scientific papers, right? It's just that, like living in the US, we were afraid of the consequences of setting up an illegal server, and so we didn't do it. But we should have, because it would have made science better. It would have been worth the legal peril, I think. But.
So in your own lab, do you have a policy of only submitting work to certain types of journals, and how common is that? Since
the lab started, it's policy. Everybody knows when they join the lab, we only submit to open access journals since the absolute beginning. I'll say it was not the case when I was a postdoc and graduate student. So this only happened after open access became a thing. But my lab started basically just when we were starting public library science. So every paper we've ever published has been, as like sometimes you're on papers where you don't make the decision about where it's published because it wasn't really your paper. You were just helping someone else. You were collaborating. So every paper where I've been the senior author and has come from my lab has been in an open access journal or made open access by some means. And so, so that's just, we do that. It's not unheard of, but it's not common. A lot of people publish in open access journals, but they do so in a more opportunistic, just like paper by paper way, right? Like I think most people appreciate that it's valuable, but sometimes, I think our lab makes the choice that we would rather make everything we publish open than publish in Nature. And I understand why other people don't make that calculus. So so I would say disappointingly few people have that stance. More and more people have the we'll preprint everything stance, which, honestly accomplishes the same goal, right? Preprints accomplish the same goal, which is to make the content freely available. They're not as disruptive in some sense of the economics of publishing, but in the long run, they could be more disruptive. Like if everybody posts preprints, the existing publishing industry cannot continue in its current form, because no library, that's acting in a rational manner is going to subscribe to buy content that can be obtained for free, and so legally obtained for free. So it's, I think the current manifestation of people saying, "Oh, I'm just going to post preprints of everything," it accomplishes the goal. There are some questions about whether that system will continue, because obviously publishers could say, we won't review your content and publish it if you post a preprint. They do in some circumstances. For now, public opinion is very strongly against that, and I think that they would have trouble implementing such a policy. But if their businesses really start to get threatened, which at the moment they're not, there aren't enough preprints that libraries can say, you know what, we're just not subscribing to your journal. So, but I've always been afraid that will happen. And so one of the reasons that I think it's so important to get peer review built up around preprints is, there needs to be a different poll than just journals. We need to make it so that journals are not the only thing that people can aspire to do to have their work assessed. So, and that's the ideal world. To me, the ideal world is everybody posts a preprint, peer review happens around preprints, and there are no journals.
Well, Mike, thank you for your time. I think we need to wrap up here soon.
No problem.
I think this is an important area for many reasons, but the vast majority of people that are not scientists, I think, have very little or no idea how this world works. I even think a lot of people in science, at least at the level of graduate students, don't actually. No, I think
most scientists just focus on their work. They don't think about and I'm sure this is true for me and all sorts of things. the part of the problem is that this is such a like integral part of the system of science that you don't question it. So like the vast majority of scientists think about journals only in terms of what it does for their careers. And they don't think about the system of publishing. They don't think about the economics. They don't think about how it could be done better. It's just the way it goes. So yeah, so I agree with you completely. It's a topic that, like this and other topics that are like about the functioning of science, most scientists don't spend a lot of time thinking about. So
any final thoughts you want to leave people with related to this whole area?
Only just to pay attention to what happens over the next couple of years around preprints, because I think that this is the critical moment that, it's possible that, 3 years from now, the momentum for everybody posting preprints will have just accelerated. And at some point we'll reach a tipping point where your work just isn't getting any attention if it's not posted as a preprint. And when that happens, or hopefully before that happens, there will also develop a culture of commenting around preprints and peer review of preprints that is functioning, robust, and better than the existing one. And at that point in time, journals, they may not cease to exist, but they will cease to hold their sway over the scientific community. So, if you're interested in this topic, I think the place to look is around what happens with preprints and preprint review and just in general, whether the current trajectory for the increasing use of and even reliance on preprints, it continues. Because if it does, then things are really going to change for the better, finally.
All right. Well, Dr. Michael Eisen, thank you for your time, and
My
I hope
pleasure.
you have a good day.
Thanks, you too.